So let's go over section 264 really quick. So if we look at f of x equals e to the x, and the slope of the tangent line there is 2, and the corresponding point, 2 log 2. So if we graph this, f inverse of x, which is log x, then the slope of the tangent line of f inverse at 2 is 1/2. And this is not by any shape or form an accident, right? So let's go look at what happens if we generalize this and say, I have two functions, f and g, that are inverse functions of each other. So that f of g of x is x and g of f of x is x. And I do what we did with the arc tangent, arc cosine functions to take the derivative. We end up with g prime is 1 over f prime of g of x. So if on a graph that's xy, right, this g of x is going to be the y. And so this is a point, right? And we can look at the two opposing points. We've got one on the f function, one on the g function, right? And we can look at the point AB and the point BA. And what we get is g prime of B equals 1 over f prime of A. Now, you got to remember, these are the slopes. So the slope of the inverse functions are reciprocal to each other, right? So g prime is always 1 over f prime at the points that map onto each other. So if A maps onto B, B maps onto A, or AB maps onto BA, BA maps onto AB, the slope at those points are reciprocal to each other, right? So this piece is why we end up with the inverse function is a reflection across the x equals y line. All right, that's it for section 264.